Hello students, welcome to e-learning. We are going to solve one more problem of simply supported beam in this lecture. So, effect of uniformly distributed load. There are 2 point loads acting, one of 50 kN and another 100 kN over the beam at 2 meter interval apart from each support respectively. So here we are going to talk about calculation part, that is reactions. So action, we know that action should be equal to reaction. So we are going to calculate first the reactions. So reactions RA should be RA plus RB is equal to actions. So actions are nothing but 100 kilonewton, 120 into 20. 20 into 20 is UDL. Sorry, 20 into 2 is UDL because 20 kilonewton meter is acting over 2 meter span, and plus 50 kilonewton point load. Totally it should be 190. So now 190 kilonewton. So this is what RA plus RB is equal to 190. Now taking moment to calculate, because two unknowns are there, you have to take moment at A equal to 0. Taking moment at A equal to 0. It means we have to assume that if you take moment of all the forces and reactions at point A, okay, that particular moment at A should be 0. So a reaction B is going to act in anti-clockwise direction and the perpendicular distance is 8 meters here. So reaction RB into 8 is equal to 100 into 6, that is force into perpendicular distance, plus 20 into 2 plus 1, that is 2 by 2, plus 2 plus 2, then plus 50 into 2, force into perpendicular distance, 50 into 2. So this is what all the forces are going to have its moment at point with respect to point A. Next we have the calculation part done further, that is 100 into 6 is 600 here, 100 into 6 is 600, 20 into 2 is 200, and 50 into 2, 20 into 2 is 40, 40 into 5 is 100, 40 into 5 is 200, and 50 into 2 is 100. So total it is 900. Totally RA into 8 is 900. RB is equal to 900 divided by 8. Reaction B is 112.5 meters, kilonewton, and we know that reactions is RA plus RB is equal to 190. Put RB is equal to 112.5 kilonewton. So it will be RA plus 112.5 is equal to 190. Take 112.5 on the right hand side, you will get RA is equal to 77.5 kilonewton. It means we have calculated reaction A is 77.5 and reaction B is 112.5. Now coming to shear force calculation. Shear force at B right is 0 kilonewton because shear force when you stand on the right side of B will be 0. When you stand on the left side of B, it will be 112.5, that is reaction at B itself, shear force at C right. When you stand on when you stand when you stand at shear force at C right, when you stand on the right side of point C here, there is only one force acting, that is reaction force. So take that into consideration. So it is 112.5. Now shear force at C left, when you stand on just left of point C here, so it will be, there are two forces acting now. One is reaction B in upward direction and another 100 kilonewton, that is downward force acting. So 112.5 minus 100 is equal to 12.5 kilonewton. Then shear force at D. Shear force at D, we have not taken left or right because it is not a point load, it is uniformly distributed load. So there we cannot go for left and right of shear force at left right D point. So shear force at E, shear force at D first we will solve. Shear force at D. So shear force at D, when you get, you have reaction, that is 112.5, then minus 100, then minus 20 into 2. Okay, this UDL we have to take for 2 meter span because it is per meter 20 kilonewton UDL. So this answer is going to be 27.5 kilonewton. Shear force at E right. Next, shear force at E right, when you stand on the right side of E, again these all three forces are going to come into picture. So again the shear force at E right will be same, 27.5. Next, shear force at E left. Shear force at E left, you stand on the left side of E, you will have, along with these three forces, point loads, the 50 kilonewton is also going to come in picture. So answer is going to be minus 77.5 kilonewton. Shear force at A is nothing but the reaction force itself, which is calculated in the reaction calculation, that is 77.5, but it is acting upwards. So therefore the shear force at A will be minus 77.5 kilonewton. Bending moment shear force at A left, because it is a point load, reaction force is nothing but point load, so right and left it is going to be 0 kilonewton. Bending moment calculation, moment at A and B will be 0 because simply supported beam, all simply supported beams will be having moment is equal to 0. Moment at C is 112.5 into 2, because you are going to take the moment at C point, and this reaction is going to act in anti-clockwise direction. So 112.5 into 2, it is going to be 225 kilonewton meter. So it is anti-clockwise force, anti-clockwise moment, so it is positive. Bending moment at D equal to bending moment. Now bending moment at D, there are three moments, three force moments need to take. Reaction force into 4 meters, 100 into 2, and UDL into 1. So how it should be? 112 into 112.45 into 4, that is reaction, into 4 meters, then 100 into 2 meters, then 20 into 2, it is going to act in the center here, so it is 2 by 2, 20 into 2 into 2 by 2, so it is going to be 210 kilonewton meter. Now taking moment at E, so all these three forces are going to come in picture here, UDL, point load, and reaction. So this 50 kilonewton is acting on the same point, so perpendicular distance is 0, so no need of considering the moment at E itself. So bending moment at E is 155 kilonewton meter. So after getting all these moments, we are going to come up with shear force diagrams. Project all the lines of all the end points of the loads, and you are going to get a shear force diagram of this pattern. Why this inclined line is passing from D to C is because in between D to C there is UDL loading. That is why inclined line should be drawn in SFD. And in the same bending moment, you can observe there is a parabola in between D to C. So we know that moment at C moment at C is 225, moment at D is 210. But after getting this parabola, what should be the maximum bending moment here? That we need to find out. So that calculation is done here. Maximum bending moment is done here. Okay, you can find this. So assuming that maximum bending moment is acting at X distance here, see, you can see in the drawing from reaction B, it is acting somewhere at X distance, it is written. So taking moment at that particular X section, reaction B into X distance, 100 into X minus 2. Okay, so it is clearly mentioned here. So you can go through the calculation and get X, that is distance of maximum bending moment is 2.625 from point B. So that value of maximum bending moment is here, 112.5 into 2.625 minus 100 into 0.625 minus 20 into 0.625 into 0.625 by 2. You are going to get 228.9 kilonewton meter. So thank you for careful listening. For further notifications and videos, subscribe the channel, like, share and comment. If you have any doubts, you can ask your questions or doubts in the comment section.